Hi everyone, today on the healing bench we have a set of 3 LED slim panels that are 18 watts each. These are all mine and I was using them in a hallway and all 3 of them failed within a week, which was a bit strange, so I decided to dig into them and figure out what's going on and see if we can fix them. The LED panels are about 9 months old, so not really that much. They were used occasionally. They are 18 watts each and are branded as Lambario. So let's try to dig into one of the power bricks and see if we possibly have an issue there. And before we start the repair, let me thank today's sponsor, which is PCBWay. When your projects need high precision parts, PCBWay got your back on their top-notch 3D printing and CNC machining services. Whether you need 1 or 100,000 components, PCBWay CNC machining offers the speed and repeatability you crave, with parts ready in as fast as just a day. They guarantee accuracy and high precision tolerances, and their custom surface finishes make your design look and feel like finished products. Choose from over 50 materials and enjoy cost savings with low tooling investment. Plus, their advanced 3-axis and 5-axis CNC milling and CNC turning mean your parts, no matter how complex, are crafted to perfection. Jump over to PCBWay.com through the link below and unlock an exclusive bonus for your next project. Let PCBWay turn your parts needs into reality with precision and speed. To open the driver, you'll need a flat head screwdriver and just pry open the back of the case that exposes the circuitry. When working with this driver, make sure that it's been powered off for a long time, and before doing any work, make sure that you discharge the capacitor on the board because they can hold some charge and potentially zap you. So now that it's safe to work on, let's see the construction. So we have the incoming supply with a fusible resistor and a metal oxide varistor going to a full bridge rectifier that then has a capacitor and a control chip. There are 2 resistors. I will reverse engineer the circuit and show you all the components later on, but let's first see how it goes. So the control circuit, the choke, and the output smoothing capacitor, a resistor to prevent any bleeding through the LEDs, and that's about it. Both of the capacitors look okay, and I don't see anything majorly wrong with the circuit. So to be honest, I don't think that the issue is with the drivers. Let's jump to the panels. And the way that this failed was that 2 of them were slightly glowing when in the dark, while the third one was completely off. So I'm suspecting that possibly the issue is with the panels and not with the driver. So let's open one of the panels. The panels are held in place using these punches from the side. So on the side you see that there's a little punch with some sort of a tool that clamps this construction in the middle. So to open them up, you can apply pressure from the back and then just push the outer ring on the side one by one. So gently apply pressure and push upwards just to release the light from it, and it should come off. So we're left with the metal ring, and on the other side we have the construction of the panel, where at the front we have a diffuser. Next, let me get this entirely. Next we have also a piece of glass that's diffused and a reflector on the back. So let's move this aside. And on the metal plate that we are left with, we have the power coming in, and we have an LED strip going all around. Now looking at it on first glance, I don't see anything major, but let's try and measure some of the diodes. Now there is no easy way how I can show you this, but basically what I'm gonna try to do is measure some of the diode in series, starting from where the positive comes, and I have my meter set in diode mode, so that would apply a certain voltage on the LEDs. So theoretically, we should see them glow, and there they are. The first two are glowing, so that means that we have two in parallel and the rest are wired in series. So let's go around and see. Okay, so that's an interesting thing. Now only one of the LEDs is lighting up instead of the two. So this one doesn't work, but it still continues and it doesn't interrupt the circuit. So the one on the actually, because there are two in parallel, all of the current will go through that one. So that's a problem. Now let's go around. So we'll test 2 by 2. And I have the panel just sitting on the side, so it's a bit difficult to hold, but let's go over it. Again, you see this one doesn't light. So let's try and mark them. So it was this one over here. I'm gonna add a dot to the case, and then yeah, so it's this one here, and let's go all the way across. Those are good, those are good, good. Could it be that it's the last ones that are both broken? Yeah, you see, so these two are not lighting up, and I think that's our issue, because since they are not lighting up, they are disconnecting the circuit, so power can go around, but it's stopped here, and because of those two LEDs, the circuit is open and it's not lighting up. If we go here, you see that they do light up, but on the other two they don't, and there is a slight, very faint black dot on the LED. Let me try and show you that. So you see there just the slightest point of black. So now what I'm gonna try to do is to disconnect these LEDs, and I'm gonna connect this wire to the next set. So basically we're gonna jump over them and see if we can make the panel work in that way. So theoretically that should help us restore the current flow. These two, the ones that were not lighting up, this one and this one, will be a problem potentially, because now instead of the current being shared between a set of two LEDs, all of the current is passed through one of the LEDs, and potentially that's the ones to fail next. We'll see if we're gonna do anything about it, but first let's see if we can make it glow. Now, one of the challenges on working on these panels is how do you actually hold it so you can solder on the LEDs. I don't want to take out the LED strip out of the case because I'm risking it that it won't stick afterwards. So these are the two LEDs that were discontinued, so I'm gonna try and apply heat to one of those, and specifically I'm trying to heat up the one on the side, and there's the LED out on the soldering iron. Let's see, I hope I didn't broke the connection there, and I'm gonna try, let me grab some tweezers. Okay, so we have the wire out. Let's add some more solder to this other pad. And let's try to solder the wire to that next pad. Okay, so let's see what we did. Okay, so if we try the LEDs now, I'm gonna have one of the leads on the cable that we soldered and the other one on the other side, so they light up. Theoretically now the panels should work, so let's connect it and test it. Now to test out the panel, I'm gonna use my dim bulb tester. Basically this is a device that adds this light bulb, 100-watt light bulb in series with the load, so even if the load is short-circuited, it won't go bang. So you have a full video on it on my channel that you can see up here. And now all of this is connected. Let's see if we turn on the light. Let's see if it's gonna work. And it does. The light turns on, but I could see two of the LEDs flickering, and I see two of the LEDs that didn't work. So let's try to mark those that are flickering. Okay, so the other one doesn't seem to be doing it. Okay, well, at least we have it fixed for now. Let's move to the other panels and see if they have the same fault. Now this is the second panel, and again I'm looking at the driver and I don't see anything wrong. So capacitors look good, there are no burn marks or anything, so I'm suspecting that it's the panel. Once again, let's try and open this one as well and see what the issue might be. Okay, yeah, so I'll try to zoom on those. I don't know how well that translates on the camera, but there are actually two LEDs that have black burn marks on them, and the rest seem to be looking okay. Only those two. Let's try and see with the meter if they work or not. So if we go to the ones before them, they do work, and nothing on these two. Let's try the other two. Yeah, so they are definitely gone and interrupting the circuit. So let's try to remove them, and we'll just bridge this pad here and this pad here on the two LEDs. Yeah, so there's definitely no easy way of holding the panel while I'm working on it, but I have it here propped on my helping hand, and I'm gonna add some excess solder and try to remove the LED by just flooding it. And I have the iron set to 450 degrees, so we try to move a lot of heat as quickly as possible to the LED without destroying the strip. And okay, so first one is gone. Let's try and clean up that solder. I'm gonna add some fresh solder and do the same on the other one. There is a possibility that you could replace this with new ones, possibly from a donor panel, but we won't do that today. We're just gonna bridge the gap in between. So hopefully we can continue the pad and the chip, because it's running the LEDs on constant current. It's gonna take care of the rest, so they'll still work just fine. I have a piece of just some random wire, and remember, we can basically bridge any two of those because they are in parallel, so current should be able to flow. Let's trim the excess. Okay, and if we use the meter now, I'm gonna have positive over here and negative over there. So Okay, so you can see that it's now connected, and we have continuity from one side to the other. Now let's test the panel. Okay, and I still have the same setup now with the different panel, the one that we just jumped over, connected through the dim light tester. Let's see if it's gonna work. And it does. You can see that it lights up, and there are some LEDs that are flickering. I don't know if you can see that on the camera. And we have a gap in the light there where we removed the LEDs. Okay, let's check the last one as well. I'm gonna start with the driver again, even though I don't think that that's gonna be the issue. Yeah, no bulging capacitors. Everything seems okay. Let's open the panel. I'm gonna leave all of this inside. So here's the panel. Quick visual inspection. We see two black dots here. Let's test that out. Okay, so meter in diode mode. These two are lighting up, and these two are not, and the last one are lighting up. So again, we're gonna do the same fix where we remove these two LEDs and we're gonna just bridge over them. There is that. So removed the two LEDs and jump over one of the pads. Now let's connect this up and see if it works. Okay, so moment of truth, and it still works. Okay, and you can see we're missing the light output from there, and there seems to be two more LEDs that are not lighting up. But now we could end the repair here, but I wanted to go a step further, so I reversed engineered the driver, and I'm gonna try to reduce the current that goes through the panels. Let me show you that. So this is the circuit diagram of the circuit. The chip that runs the whole thing is labeled as 1FYL9T2CC. I wasn't able to find any datasheet on it, but I found similar looking chips that I was able to make out the circuit. So on the input we have a fusible resistor of 3.3 ohms that's connected to a bridge rectifier that's down there, and across the contacts we have a metal oxide varistor labeled 070471K. The bridge rectifier is labeled MB10F, and it has a 6.8 microfarads 450 volt capacitor on the output. That's this one, the big one here. And then the power goes to the chip on pin number 4. Pin number 1 is connected to ground. Pin number 2 is connected via 30K resistor to ground. And we also have on pin 7 1.65 ohm resistor also connected to ground. And I was able to work out that that's the one to set the current. On the output, both of these contacts on pin 5 and 6 are bridged together. They go to the inductor. They have a diode across there to suppress any peaks. And on the output we have a 2.2 microfarads 250 volt capacitor and a 300,000 ohms resistor across that to prevent any dimming. And then on the end we have the string of lights where we have a series of 2 parallel LEDs, and we have a total of 45 such series in each of the panel. And that's basically it. I'm gonna actually try to increase the resistance of this resistor here. I don't have any surface mount resistors, but I'm gonna try to find a through hole resistor to increase it to 3 ohms. So this is 1.65. Increasing it to 3 ohms should theoretically reduce the output current to half of what it is. Let's see if that works. Okay, so I don't seem to have a 3 ohm resistor, and the best I have is 1 ohm and 8 ohms. So I'm gonna first try to see if I can add a 1 ohm resistor in series with the 1.6 ohm resistor. Otherwise, I'm gonna try and add 2 in parallel. Let's see how that goes. It will be a bit tricky because this is SMD, so it's not that easy to solder. Okay, so that went pretty well until it didn't, because when I moved the 1.65 ohm resistor to the side and tried to solder on it, that went fine. But then I tried to bend the resistor so I can bend the capacitor back, and I actually broke it, and it's no longer conducting. So the closest thing I have that I did is to add 2 8 ohm resistors in parallel to get 4 ohms. So let's try it out, and we will first run one of the other panels that has unmodified controller to measure the power output of it and see how this one compares to the other one. Okay, so this is the unmodified panel, and I'm turning it on, and it draws about 17 watts. And this is the one that we bridged one of the contacts. Now let's connect the other one and see how that one goes. Okay, so here is that one, and we are working with live voltage, so make sure that you're safe, that you know what you're doing, and make sure that you have everything disconnected when connecting or touching or handling any of the exposed wires. Now let's turn on the modified panel and see what happens. Okay, so nothing really happens. That's strange. We had the 0.3, so 1.3, and then it drops down. Okay, that's interesting. Okay, so that did not seem to work at all. So I removed the 2 parallel ohm resistors and I added 2 1 ohm resistors in series. So we now have a total of about 2-ish ohms. I measured it and it comes with slightly higher than that. So it's close to the original 3 ohms that we wanted to do. And let's see now how the panel behaves. I suspect that previously it just didn't had enough current running for the LEDs to light up. Let's see now. And they do light up. And we are down to 14 watts instead of the original 18. This again outputs plenty of light. And I think next I'm gonna close everything up and see how both of these compare in, and if we could see any difference in the light output. So let's turn this off. Okay, so we now have the 2 panels wired in parallel. So when I turn it on, both of them will turn on, and the one on the right I marked with L, and I also marked the power supply with L, meaning that that's the one that we lowered, and this is still the original one, unmodified, except when we jump the LEDs. So now let's turn them on, and I'll keep the auto adjustment on the camera on so we can see if we have any difference in the light. Now they're both on. Both are using about 31.2 watts, and I don't know if that translates on the camera, but I don't see any visible difference in the light output, although this one is using a bit less energy, and hopefully that would keep the LEDs cooler and that would make it last a bit longer. Now let me try and keep the brightest on, and let's see if that makes any difference. with the eyes, they both look identical. So I think we did a good job, and we actually made one of them to be slightly less in power consumption. Now I tried the variant where I've added 1 ohm resistor in series with the 1.6 ohm resistor, and that seems to be working this time, and I managed to do it. So let's try how that will compare. Using the two 1 ohm resistors got us to about 14 watts, and this one, let's see, and this one is down to 10. So now that's even better than before. So as I said, around 3 ohms is basically getting us at half the intensity. So now this one is using only 10 watts instead of the original 18 or close to 18 that it was before. An interesting little quirk that happened with the series of 1.6 and 1 ohm, so close to 3 ohms, is that when I turn it off, now the lights flickers. When it goes into, I'm guessing, some state that it still have enough power in the capacitor to run for a bit, but not long enough, and the IC is trying to restart the LEDs. So every time we turn it off, we get a bit of a light show. So I'm guessing that going with the 2 resistors in series would be the best option to modify these power supplies. And here now, all 3 of the lights fixed and modified in the controllers, so they use a bit less of energy than they originally were using. The 18 watts, now we are down to about 14 watts, and hopefully that would make them last a bit longer. I won't be using this in anywhere where it's difficult to be accessed. I'll probably keep them as spares for now, because I saw that some of the LEDs on the strips were already flickering, so I don't think that they're of good quality, but they could be a nice replacement in a hurry, or depending on the application, I might use them somewhere else in the house. And with that, I hope that you like this video. Make sure that you like it down below. It helps me a lot. Make sure to subscribe to see me do more repairs and more projects in the future. If you have any questions, leave them down in the video comments, and I'll see you all in the next one. Cheers!